Hello everyone, this is now section 3.4, which is about chain rule. All right, so before we go into this section, first we need to know about the composite functions. So the composite functions, So the composite functions are, let's say if we have two functions, h of x is equals to x to the power 3 and g of x is equals to 2x plus 1, then the composite functions means a function of well, if we have a function, basically, let me just write it first and then it'll be easy to explain. H of g of x. So this function, g of x function, is inside this h of x function, right? So these kind of functions, we say h of g of x, right? So these kind of function, we said it is a composite function, right? So h of g of x, we can find this, which is h of, well, g of x is 2x plus 1, right? Because g of x is 2x plus 1. And now from this h function, which is x cubed, we replace this x by this whole thing, right? So which will give 2x plus 1 to the power 3. All right, so these kind of function, we say it is composite functions, right? So now, okay, so here, the chain rule, well, on the chain rule, well, let's say chain rule will be, let's suppose f of x is a composite function, which is like these, f of x is equals to h of g of x, all right? So this is a composite function, right? So if you see like this, a function, there is a function within a function, and these kind of function is called a composite function. So here, if I want to take the derivative of this function, then let's say if I want to take the derivative of f of x, then I have to take the derivative of, so first I have to take the derivative of this whole thing. So since this whole thing is h in terms of x, or the name of this whole function is h, so take the derivative h, and the g of x inside will stay the same, and then after that times multiply by the inside this g of x function. So first take the derivative of h, and then take the derivative of this inside function g of x. So yeah, this rule is called chain rule. All right, so let's see an example. So let's say we have a function within a function. Let's say a first example, f of x is equals to, okay, so before I do the example of chain rule, well, we know that when I take the derivative of, let's say, just these kind of function, 3 times x to the power 4 here will be just using power rule. Well, this 3 will stay there, and we just have to take the derivative of x to the power 4. So this 4 will come down here, and just, you know, we're going to have a new power, x to the power 4 minus 1, right? Which will give 3 plus 4 is 12, x to the power 3, right? Now, well, this we have done it, but the thing is, now when we want to take the derivative of, let's say instead of just 3x, let's say we have 3x plus 1 to the power 4. All right, so we want to take the derivative of these kind of functions. So now there is this extra plus 1 inside this this thing, the fourth power inside this, the power 4, right? So here we're going to use the power rule. So first we have to take the derivative of, well, like I said, when we have something like this, we take the derivative of the whole thing and then take the derivative of the inside function. So the same idea here. So take the derivative of this whole thing. So we have 4 on the power. So we are going to use the power rule here again, right? The power rule says that if we have a function of x is equals to x to the power n, then f prime, or the derivative of this, is equals to n times x to the power n minus 1, right? So here we bring this 4 down here, so that will be 4 times 3x plus 1 to the power 4 minus 1, which will be 3. All right, so that's the derivative of the whole thing, times, now take the derivative of this inside function. So the derivative of the inside function, well, the inside function is 3x plus 1. So when we take the derivative of 3x plus 1, first we're going to take the derivative of 3x. So this will be just 3. So derivative of 1 is still 0, so plus 1, so plus 0. So derivative of 1 is 0, right? So that means, well, yeah, this will be gone. So we just have to multiply this 3 to this 4, which will be 12. So 12 times 3x plus 1 to the power 3. So that's the final answer. Okay, so e to the power negative 3x. All right, so again, when we take the derivative of this one, f prime of x is equals to, now we have to take the derivative of this whole thing. So we have e, right? So when we take the derivative of e, it's same thing, right? Because we know the derivative of e to the power x. Let's write this. When I write like this means a prime, so I'm taking the derivative of e to the power x. So this will be the same thing, e to the power x. All right. Okay, so here instead of x, now we have negative 3x, right? So first, when we take the derivative of this whole thing, it will be the same thing, e to the power negative 3x. But since we have here negative 3, so we have to take the derivative of this negative 3x. So the derivative of negative 3x is what? So when we take the derivative of negative 3x, so first negative 3 will stay there, times the derivative of x is just 1. So that's why it is just negative 3, right? So the derivative of negative 3x is multiplication, right? So times negative 3, right? So this one I can write negative 3 times e to the power negative 3x, all right? Similarly, let's say natural log of x to the power 3 plus 4. So what is the derivative of just natural log of x? Well, we did this in last section. Then the derivative of natural log of x is 1 over x, right? So here now, instead of this whole thing, okay, first when we take the derivative of this whole thing, the derivative of natural log of x is 1 over, well, since there is an x here, that's why we have 1 over x. If there is something else here, it will be 1 over that thing. So here we have this whole thing, x cubed plus 4. So when you take the derivative of this whole thing, it will be 1 over x cubed plus 4, right? Now, since we have, instead of just x, we have x cubed plus 4, so I have to take the derivative of this inside part as well. So when we take the derivative of this inside, the derivative of x cubed first is, well, we bring this 3 down here, 3 times, let me use the same color. So 3 times x to the power 3 minus 1 will be 2. And the derivative of this is 0, right? The derivative of 4 is 0. Okay. Now let's take the derivative of, let's say we have f of x is equals to 1 plus e to the power x square, all right? Again, to the power 5. Okay, so now here when we take, okay, I forgot to write derivative of f, or f prime of x. All right, so when I take the derivative of this one again, f prime of x is again, so this 5 is on the power, so I have to take the derivative of this whole thing first. All right, so when we take the derivative of this whole thing, I can use the power rule, so I can bring this 5 down here, times 1 plus e to the power x square, so x square to the power 5 minus 1, right? That's the derivative of this whole thing. Or instead of writing 5 minus 1, just write 4. All right, so that's the derivative of this whole thing. Now let's take the derivative of this inside thing, this inside function. 1 plus e to the power x squared. So times, all right, multiply by this inside, which is 1 plus of the derivative of 1 is 0, which will, yeah, we don't have to write that. Now the derivative of e to the power x squared is, when you take the derivative e, it will stay the same. So we have e to the power x squared. So when you take the derivative of that, it will be the same thing, e to the power x squared, right? So when you take the derivative of e to the power, we already have here. So when you write the derivative of, when you take the derivative of e to the power x, then it's e to the power x. When we have x here, there will be x here. But now instead of x, we have x squared. So that's why we have to use another chain rule here again. All right, so times, now once we take the derivative of e to the power x squared, we did that, right? So after that, I have to take the derivative of this x squared as well. All right, so derivative of x squared is 2 multiply, all right, there is a multiplication here and here both, and x 2 times x to the power 2 minus 1. So this is, we're taking the derivative of x squared, all right? So this x squared. So 2 minus 1 is just 1 to the power 1, which will be, well, we wouldn't have to write that, all right? So now I can just rearrange my answer. So, or just multiply this 5 and 2, which will be 10, times x, times this e to the power x squared, times this, these things, 1 plus e to the power x squared to the power 4. All right, so yeah, this is the derivative of this function. Okay, so now this is the last example. Okay, so this is number 6. F of x is equals to 2x squared times x to the power 3 minus 3 to the power 4. Okay, so here we have two terms. are two function multiplying each other, right? So let's say if we have f of x is equal to h of x times g of x, right? So here we need to use product rule, which we have already done it. I think we did this on section 6.3, I guess. Sorry, 3.3. Yeah, we did this in section 3.3. So we take the derivative of this. Then first I can take the derivative of h. It doesn't matter. You can take the derivative of g. In that case, h will stay the same, right? So let's take the derivative of h first. So h prime times g of x will stay the same, right? Plus, then now h of x will stay the same, and then we'll take the derivative of g. So g prime of x. All right, so this is a product rule. So here we need to use the product rule first. All right, so since we have these two functions multiply to each other, so first let's take the derivative of this 2x squared. All right, so I can say this is h of x. I can say this whole thing as g of x and use the product rule of this. So first, when I take the derivative of 2x squared, it will be, so 2 will stay the same. I bring this 2 down here. So the derivative of, this is now x to the power 2 minus 1 will be just x, right? So, okay, I took the derivative of h first. Now this g of x will stay the same. X to the power 3 minus 3 to the power 4. All right. So we did this part, right? First. Now plus. Now after that, h of x will stay the same. So that means this first one will stay the same. So 2x squared. And then now take the derivative of this second one. So first I have to take, okay, so I have 4. So now here I have to use the chain rule. All right, so the first, now take the derivative of this whole thing, which will be, okay, times 4. Okay, we bring this 4 down here, 4 times x cubed minus 3 to the power 4 minus 1 is 3. All right, times, now take the derivative of this inside using the chain rule. All right, so using the chain rule, if I take the derivative of this inside, well, first I have to take the derivative of x to the power 3. So x to the power 3 will be, 3 will come down here. So 3 x to the power 2, right? And minus derivative of 3 is 0. So we don't have to write that. All right, so yeah, that's the idea. Now we just have to now rearrange our answer, or if we have to combine, if we can combine anything. So let's see. So here, 4, right? 4x times x cubed minus 3 to the power 4. All right, so that's the first. And for the second one, well, all of these are multiplying. So 2 times 4, 8. 8 times 3 is 24. And x squared, x to the power 4 times this x cubed minus 3 to the power 3. All right, so here I used two things. I used, for this one, for this whole thing, I used product rule. And then here on the second part, or in the second, yeah, I can say the second part. For the second part, I used the chain rule as well, right? So yeah, keep this in mind, all right? Because you will see something like this on the homework problem as well. All right, so yeah, I think that's it for this section. All right, so I'll see you in the next section. Thank you.